So welcome to my HL series. So in this video we discuss about superconductors. So the superconductors, the ability of certain ultra cold substance to conduct electricity without resistance is called superconductivity. Substance having this property are called superconductors. So thus a superconductor is a conductor having almost zero resistivity and also behave as a diamagnetic below superconducting transition temperature. So the superconducting transition temperature Tc of a material is defined as a critical temperature, so at which the resistivity of the material is suddenly changed to zero. So thus that temperature material is changed from the normal material to superconductor. So in the transition regions of finite width, that depends upon the presence of impurities and the internal stress in the sample. So the temperature Tc pure metals range from 0.35 Kelvin to 9.22 Kelvin. So and of semiconductors from 0. Kelvin to 1.25. So commonly always have a higher transition temperature. So particularly BDM compounds such as Nb3Sn and Nb3Ge so have a higher transition temperatures. Copper oxide ceramic superconductors have a high transition temperatures. So and so they are technically important superconductors. So at the transition temperatures of the following physical changes are observed. So the electrical resistivity drops to zero. So the magnetic flux lines are excluded from the material. So there is a discontinuous of so there is a discontinuous changes in a specific heat. Further, there are also small changes in the thermal conductivity and volume of the material. So superconductor definition, substance that offer no resistance to the electric current. So when it becomes colder than the critical temperature. Some of the popular examples of superconductors are aluminum, magnesium, diboride, medium, copper oxide, yttrium, barium, and penticides, and these substances superconduct at temperatures below the critical temperature. And then critical temperature, the critical temperature for the superconductors is the temperature at which the electrical resistivity of metals falls to zero. So most materials superconducting phase transitions at low temperatures. So the critical temperature is the temperature below the material changes from the conductors to superconductors. The critical temperature is called transition temperature. So the transition for conductors to superconductors is sudden and complete. And next one, Meissner effect. So these are the properties of superconductors. So the electrical resistivity drops to zero at the transition temperature. So superconductors have virtually zero electrical resistance and can conduct electricity without resistance. So diamagnetic property, this material can behave superconducting only when the resistivity of the material should be zero and the magnetic induction in the material should be zero when it is placed in a uniform magnetic field. So both the conditions are independent to each other, and to get superconducting state, these two conditions should simultaneously exist in the material. And then magnetic field. So the minimum field required to destroy superconductor is called a critical field. So the material of the material. So thus the value of the critical field depends upon the temperatures in the superconducting material. And effect of heavy current. So these are the properties of superconductors. So next class we discuss, next video we discussed Meissner effect. Thank you.